Welcome back. My name is Kirsten McMillan.
And my name is Glenn Milner.
And we are with the Climate Risk Institute. So in this course so far, you've learned a lot about why it is important to bring together interdisciplinary teams. There's also some challenges in bringing these teams together, especially with communication. Today, we're going to walk through a few examples of how you can help to facilitate conversations between climate and engineering experts.
So when we think about communication on climate teams and as part of risk assessment, we really need to think about the right information to inform our decision making. So we want to be able to work collaboratively, and we need to be able to understand each other and find some common ground. So all of this can be kind of packaged as being the need to communicate effectively. And when it comes to communicating effectively, we know that we can often face barriers, particularly as they relate to interdisciplinary teams. So for example, you might face different languages, different terminologies in the same discussion. You might find yourself facing a different understanding of the same objectives across different types of disciplines. And of course, you might actually have different understandings of disciplines themselves. And so it's important to really build consensus, find that common ground, and share individual perspectives.
So we're going to walk through a few different examples where I will be the engineering expert and Glenn will be the climate expert, and we'll show how we may bring different perspectives to the same question or the same area of the project, and how we can come together to understand each other's differences and come with a solution together. So, as an engineer, I'm looking for information on rainfall, and I know that we need the most conservative value for what rainfall may look like in 50 years. I want to know if large floods are more likely to occur, but I don't know if global mitigation efforts will be successful. Therefore, to be the most conservative, I will use a high emission scenario.
And that's very important to understand that that's very different from the climate expert's perspective. So when I hear the term conservative, extreme scenarios from a climate perspective have more uncertainty, and averages may actually be more accurate. And so therefore, to be more conservative from a climate science perspective, I may choose to use more of a lower emissions scenario that I know might have slightly more confidence, particularly in the short term.
So obviously, we both need to talk.
And so in this case, it's really important to recognize that these are very different. We actually, in this case, have opposite understandings of what a conservative approach might look like for something. And so a good idea of finding common ground is to look at a range of scenarios. So that might include a lower and a higher emission scenario that would be most appropriate for a particular project. But critically, we need to work together to understand the outcomes and really what we hope to achieve from this climate data and where people really find that understanding of a scenario for future planning and future decision making.
So our next problem we're facing on a project. I need to know exactly what flood levels will look like in 2063, and I need to be confident that there are no uncertainties in the climate data. So as an engineer, when I'm hearing uncertainties, I may think that we can't move forward with the design until we can confirm all of the unknowns.
And this is actually a request that climate experts and climate scientists hear a lot, which is they want a one value on a particular day or for a particular condition. And my response is that I can't give climate data with no uncertainties. So we cannot really move forward until we address several other questions around uncertainty and needs and really how to accomplish this need from an engineering perspective. So all climate data has degrees of uncertainty in it baked in.
So in order to move forward, again, we need to talk. So now that we've had these conversations together and understand that we can't have just one number for the future, we can work together to establish our tolerance for uncertainty based on what we're hoping can happen with this project. So together, we will be able to use this information to create future scenarios and have a better understanding of what is possible in the project. So, next question. I am an engineer and I need climate data. All data is data, so just send it over when you have a chance.
And from a climate expert's perspective, we immediately need to know what kind of data. Are we talking about a combination of measured, interpolated, and climate model outputs? Are we talking about raw climate data itself? there is a very important distinction between the data that's in and run in a model versus that's post-processed after the fact, in addition to what's measured or observed. And so what kind of data? And so in this case, we ideally need to identify the relevant climate change data to a particular project, which requires, of course, collaboration. So let's start with an understanding of what project design information is needed and how can we base that upon our understanding of current vulnerabilities. So we can assess, for example, the confidence in data, its potential limitations, and that way we can find ourselves on the same page.
So as the engineering expert, it's important that I don't say we need all of the climate data tomorrow. We obviously need to have a discussion and come at it together. So next we'll walk through some of the examples of what an engineer typically needs or may ask for on a project, and then Glenn will give an overview of what the climate science can provide or some of the limitations. So one thing that I would often be looking for is extreme events. So I want to know about extreme flooding or snowpacks or wind and how this would impact the infrastructure that we're assessing.
And what climate science can actually provide us is best with averages. So if we were to take an extreme event and really analyze it, that requires highly specialized approaches. And so that is important to scope into a process if it's critical for a decision. But we also have to recognize that some future trends are not yet certain or have very, very low confidence. A good example is snowpack can be particularly challenging to project into the future. So acknowledging the degree of uncertainty and recognizing what the best approach for climate science is important to reconcile that difference with the extremes.
So if I was looking at an assessment on a dam, I may already have a hydraulic model available. And I might ask the climate scientist for sub-hourly extreme rainfall down to the minute projected into the future.
And this is a very common request as well among climate science and experts. And really, we often have to say that climate modeling and projections are best at the daily to monthly scales, particularly as it relates to extreme rainfall. And there are several reasons for this, but it's often because extreme rainfall and precipitation is highly localized and driven by different atmospheric conditions. And so the uncertainty increases as we kind of move into finer time and finer space. And so if one were to downscale to a kilometer by a kilometer to minutes, for example, you have a much higher degree of uncertainty. And so we have to make sure that that's possible. And if it's not possible, we need to make sure that's very clear to the engineers involved in a project.
So finally, I'm also interested in looking at complex climate events because I want to be realistic about what can actually happen. So I might be thinking about snow followed by rain, followed by ice with high amounts of wind and how all of these could add up together and impact the infrastructure.
And this is a very interesting request because it's very difficult to actually combine and calculate some of these more coupled events in climate change as we move into the future. But that being said, there's a really important opportunity for professional judgment for these types of requests from climate scientists, because they can not only paint a picture of what has happened in the past, where some of these complex climate events may have occurred, but how that might change qualitatively moving forward into the future. So there's an opportunity here to not necessarily focus on quantitative data, but create qualitative narratives or scenarios that could occur to inform work from that perspective.
So through these examples that we've provided today, what we really want to emphasize is that you cannot underestimate the power of good communication on teams. When you're establishing a project, you should always take the time up front to speak with everyone and make sure that we know about each other's skills and expertise. Also, don't be afraid to ask questions. So in some of these examples, we could have carried on with the project for months and months with completely different understanding. So we need to pause, talk to each other, and ask questions when we might not understand things from the same perspective. And this will really help your project be much more successful. Thank you for joining us for this session.